Hi everyone, this is Danilo from QET, and I'll be presenting my wireless sensor network proposal for a sugarcane company in the Philippines. So our case study is for Victoria's Mining Company, located in the central Philippines with a market share of 12.63% in the national sugar industry. But in 2017, their business was plagued with declining revenues due to competition and low crop yield. And in order for them to sustain their competition, they plan to improve their process efficiency and crop monitoring through the implementation of a wireless sensor network. We have four key stakeholders in this case. Number one, or first, is Linley Retirado, which manages the quality analyst team of VMC and has been with the company for 25 years. Next is Teresita Ilagan from finance, and she always views efficient processes as revenue-generating services for the company. Eva Rodriguez from the administration group, her main concern is to always avoid downtimes. And Mr. Eduardo Concepcion, the president, CEO, and acting CEO of the company, he's been with the company for 30 years and he started as a sugarcane farmer himself, and he has a thorough understanding of the processes in the sugar milling, and he plans to improve the crop yield of VMC to improve their pricing strategy. Three wireless sensor networks will be used in this proposal. Smart Gases Pro 3.0 senses gases such as carbon monoxide, carbon dioxide, ammonia, hydrocarbons, oxygen, methane, and air pollutants, and it outputs a value indicated in ppm or parts per million. Next is the Smart Agriculture Board, which senses air and soil temperature, soil moisture, humidity, wind speed, pressure, and solar radiation. The data gathered are converted into analog voltages values for transmission purposes. Last is the Smart Water 3.0, senses irrigation water's chemical composition such as dissolved oxygen, pH, and various ions. And it outputs a voltage proportional to the chemical concentration measured and amplified using analog to digital conversion. All of these three sensors are compatible to use with some of the industry standards in wireless sensor networks, such as Zigbee 802.15.4, Sigfox, LoRaWAN, 3G, 4G, etc. Our connectivity diagram starts with three sites, and each site has their own network gateway using Meshlium. And the three Meshliums connect to a fog network. The fog network basically aggregates the data from these sensors, and it acts as an intermediate management and orchestration layer. And the fog network then throws the data to our cloud infrastructure. Cloud infrastructure is a more intensive and high process capacity repository, and it also has the orchestration and management, web and app servers, and as well as in-depth analytics. Our fog computing analysis starts from sensing and gathering data from the sugarcane fields and sends it to our network gateway using Zigbee or 802.15.4 protocol. Our network gateway is using Meshlium, and it aggregates connections from different sensors. These gateway then sends the data to our fog network or fog infrastructure. Fog infrastructure still contains the network, compute and storage, and as well as initial analytics and categorization of data. This eliminates latency and improves data management. It then throws the data through our cloud infrastructure. Cloud contains more intensive resources and high processing capacity and performs in-depth historical data analysis. And on to our users for their web-based portal to view the generated information. For security threats, we have two, which are the denial of service attack and as well as the Sybil attack. Both are common to wireless sensor networks. We also have the intrusions, malwares, spywares, and as well as physical theft and force majeure. And to combat these security, we have four measures. GPS module to always detect the device's location, cloud-based security to protect our fog and cloud infrastructure from other viruses and malicious connections, encryption like RSA and AES to protect our data in transit and data at rest information, and as well as disaster recovery solutions for resiliency and redundancy purposes. In conclusion, this proposal intends to show VMC the value of monitoring the crop yields and what insights can be derived that will be helpful in steering their business. And this proposal can encompass or can extend to their asset tracking and to their sugar milling equipment for them to have a holistic view of understanding the business standpoint. So that's all for today, and thanks a lot for listening.